Hi, my name is Andrei, and this is my Machine Learning Foundation for Product Managers course project. For this project, I created a GitHub repo. Inside the repo, you'll find two files. The first one is CSV file, our dataset. The second file is a Jupyter notebook. To play with the project and maybe evaluate the results, you can use the Jupyter notebook. The Jupyter Notebook contains the project description and the steps I've taken to build the project. Let's review the project steps. The first step is to select the type of ML approach. What we know about the dataset is dataset is organized as a table in the CSV file. We have 5 continuous columns. 4 columns can be used to train a model. Therefore, we have 4 features. The PE column represents values we want to predict for new data. It will be our target. The problem we are solving here is prediction problem, hence a regression problem. To evaluate our model, we can use root mean squared error, which is sensitive to large errors and quite interpretable since it's in the same unit as our target variable. The next step is to think about possible machine learning algorithms. To predict the electrical energy output of a combined cycle power plant, we can use all 4 features. We can try the following models: linear regression and its variants, which could be a good baseline anyway. Tree-based models like random forest regressor and gradient boosting regressor, which are effective for handling nonlinear relationships. Since our dataset doesn't have complex relationships in the data, using neural networks or deep learning will be overkill, at least in my perception. To validate selected models, I'm going to use 5-fold cross-validation strategy. That strategy can offer a robust performance comparison among models without being overly computationally expensive. Because I'm using Python in this Jupyter notebook, I'm relying on pretty popular Python libraries such as NumPy, Pandas, and scikit-learn. Now, let's quickly review the code. We load the dataset. We'll split it in training and test data. Then we define features and the target, as well as instances of the selected models. We have 3 of them. We define 5-fold cross-validation object. Inside this loop, we iterate over our models and we cross-validate them to calculate our metric, which is root mean squared error. Finally, we print all the metric values for each of the models. And it seems that the best model, if we believe in our metric, is random forest regressor. Given that the random forest regressor has the lowest matrix value, root mean squared error, we'll select it as the final model. To evaluate the performance of the model, we'll train the random forest regressor on the full training set and then calculate the metric value again on the test set. Running the following code will give us the test metric value. Here it is. The test root mean squared error indicates that the model performs well on unseed data. To conclude, among 3 of the selected models that I listed in the beginning of this project, the random forest regressor model is the best one. Thank you for your attention and have a good one.